Within the scope of the project Boost 4.0, we're looking at a production line of the automotive supplier BENTELER, on which, for example, structural parts for automobiles are manufactured. The production line consists of various subsystems, for example industrial robots, an oven or a hydraulic press. If this production line is equipped with sensors, information about the conditions within the machine and also the condition of the machines can be collected at different points. Maintenance of such a system is important to ensure a highly proficient production. Although we have planned regular maintenance events, unplanned incidents still occur. That could, for instance, be the leakage of oil in a hydraulic press system, or the pileup of scrap metal during transportation in an underground tunnel. Since a production stop is necessary for maintenance, the prediction of machine failure offers tremendous advantages. The data collected by the sensors is stored centrally and enables, on the one hand, monitoring of the machine status. On the other hand, this data can now be assigned to different machine states and patterns can be recognized. For this purpose, we use approaches from industrial analytics, for example machine learning methods, anomaly detection or prediction models. This way, the condition of a machine can be predicted. For BENTELER, this means forward-looking and more efficient maintenance planning. Machine errors can be predicted and thus be avoided if necessary. In the leading-edge cluster ITS OWL and the enabling center Digital in NRW, such practical solutions are also being made available to small and medium-sized companies. Because artificial intelligence is something for everyone and not just for the big ones.